Hello, this is for CHAID. So CHAID is a type of decision tree, and we use decision trees for either prediction, classification, looking at interactions between variables. Something unique about it, it's not on parametric test, so you don't have to look at normality of the distribution. Another benefit is that it's visual, so it's pretty easy to interpret. If you don't have a lot of statistical knowledge, it'd be easy to present to a group of people and have them kind of understand and walk them through it. It works best with large samples of people. My sample was not that large, so you'll see that doesn't really tell us much, but we'll get there. And when you have a lot of variables, so these are good when you are trying to make conclusions based on a lot of different variables that you have to deal with. So to get started, we have to install the CHAID package to R. Great. And then next, there's a couple different packages that you need to run the CHAID, so we will install those as well. And then next, we will library all of those packages to make sure that they're in R. Okay, great. I've already imported the data set. It can be seen here, CHAID data. But I'm going to attach that so that R can find it in the search path. Next, I will be turning the variables from the data set into factors so they can be recognized by R and read for the CHAID analysis. So I made up data of different groups of teachers, English teachers, math teachers, and science teachers, their performance scores. So if they had decreased performance, equal level performance, or increased performance from the previous year. And then favorite colors. So I picked blue, purple, red, and orange. Broke down then gender. I only picked two things for gender, male and female. And then education as my final factor. So there was two groups in there. It was if you were a teacher with a high school or college level of education versus post-grad. And then in order to make sure that each variable was turned into a factor, I'm just going to run these to double check so that the way the model works later. And you can see here that all of these are true. So that means that these have all been changed into these different factors, which you'll see in the model. So the next step is setting the parameters for the model, including the confidence intervals. So we're looking at the least significant difference between, with respect to the dependent variables. So the way that the CHAID works, there's going to be merging and splitting of different categories. And they're using a Bonferroni adjusted p-value. This value is going to be anywhere that you can set between 0 and 1. Obviously, we use 0.05 for most of our statistical testing for significance. If you made that number larger, you would get more nodes. You'd be more likely to see different types of interactions. The smaller numbers produce generally less nodes. So you'll see that mine doesn't have that many nodes because I don't have a data set that had many significant findings. Next, we are going to actually name our CHAID model. So what we're going to factor into, we're going to follow this with the CHAID command. our outcome variable, which is our dependent variable, which I picked as a favorite color. So if you can predict favorite color from those different factors listed above, so education, which group, which type of teacher you were, your performance, and your gender, pulling from chain data, and then the control that we made above with those parameters set. Next, we are going to actually do a print of the CHAID. And this kind of gives us information without actually showing us a visual representation in our output of what our root and our different nodes are going to look like. So it'll tell you the number of people in each group, the errors, and number of people, the errors, our root variables, and the number of inner and terminal nodes present. So there's going to be 2 nodes coming off of our main, and then there's going to be ultimately 3 terminal nodes at the end of our decision tree. This next one actually plots the model, so we're going to be able to see our model over here. And from this, we can kind of make some initial just decisions based on the visual representation of it. So when we start at the top, we have our root node, which is gender. So we can say that gender is like our highest predictor of what your favorite color would be. It's a little bit of a sexist model. And then coming down from there, so gender 1 is males, 2 is females. And then next would be education. So this is like a parent node. Usually there would be more that split off of this before we get to the terminal nodes down here. But this is the parent node of education. So 1 is the high school and college level teachers, and then 2 is the graduate teachers. So colors were blue, purple, red, and orange. So we can see that blue and purple were popular amongst men who were in the high school and college section. And then next we go over to the other one. But if you went to grad school, I guess you liked red more. And then for females, we see the highest in orange. All right. And then this last one actually shows us if this were something that we were actually going to use to predict and kind of make some assumptions and work backwards to figure out maybe why these different groups existed. This is more of what we would use, because it's going to give us that both the number of people in the group, our error values, the chance of making like a wrong prediction, and then what the actual highest factor within very specific determinant within the factor was. So we had said that we had kind of looked at the first ones and thought that the blue and the purple were the same. So this is showing that blue is slightly more likely. And then over here we see that red, once again, that bar was higher. So the prediction is going to be a little bit lower in percentage than those that were very close. You may make the wrong assumption here. And then over here, we see that orange that we saw on the previous one. So the different nodes, it's just, you remember that the nodes are the people in each node share characteristics that are similar. And this can be used in more useful ways than what I had come up with, but good for, as we talked about, recruiting, or when you have a lot of different variables to look at and you want to try to make some assumptions about maybe the different types of groups and their reasons for doing certain things. All right, bye.